Hello everyone, welcome back to the lecture. In my basic, that is construction methodology course, we had understood the types of the building system. And there I had explained you about the flat slab system. Usually when you want the distance between the two column to be on a, whenever the distance between the two columns should be more, so that you will have enough area for the movement. In that case, we usually go with the flat slab structural system, especially in case of commercial building or let's say in the mall construction. If you go to the basement area and all, I told you that usually you find such kind of structural systems over there, right? This was the main thing which I had explained. And why and what is the problem with this particular flat slab system is about the punching shear. That is a two-way punching shear. Suppose if I take this as a slab and just 1 minute. Yeah. Suppose if I take this as a column and this is my slab. So when the load comes, it will try to punch like this. This is called as punching shear. So in order to avoid this punching shear, I have two options. Either you increase the size of the column or you can increase the slab thickness. So what I told is usually let us say I'll increase the slab thickness. Now instead of this thickness is more. Now if I try to punch, it won't punch, right? So that is a general thing or general behavior of a flat slab system. You had this much idea. Now we'll understand one step more and we'll try to see the sequence of construction and all the concepts now. Now I'll take you to the flat slab part. Yeah, just 1 minute. Yeah, so according to the Indian Standard Code Book IS 456-2000, what is the general definition of the flat slab? It is mentioned the term flat slab means a reinforced concrete slab with or without drop, supported generally without a beam, by column with or without flayed column heads. Okay, rest point is not needed. So like I mentioned, in the flat slab, you usually don't find any beams. Beams you will give, but that will be in the periphery, but not inside. None of the column will be supported by the beams. Now we'll try to see what is this with or without drops. What is this flayed column? We'll try to see that. Okay, so generally in the flat slab system, we have these four types of system. So this one is called as a flat plate system. This is called as a flat plate. Here we have a column and directly over that you are giving a slab. So this is called as a flat plate system. Okay. Next one what we have is a flat slab with a drop panel. Here we have a column, but wherever you have a slab, no, below that we have this thing. So this is called as a drop panel. The next one what we have is a flat slab with a column head. So we have a column here, but this column is extended like this. So I told you whenever this punching was happening, I had two options. Either I told you to increase the size of the column or to increase the thickness of this. And also told you usually the architect will not allow you to increase the size of the column. Usually what we do is we increase the depth of the drop panel. But sometimes the architect has a problem only in this layer. Architect will not allow you to increase the size of the column in this up to here, because if you increase the size here, it will be seen, right? But you can just increase the size of the column somewhere here. At this portion, you can increase. Got it? So this is called as a column head. But again, generally, we don't practice this also because it is easy to do on the paper. Construction of this is very difficult. You have to give a kind of a cone here, then the shuttering is difficult. That is the reason generally we don't go with a column head also. Again, this is given from punching shear only. Either you increase the size of the column or increase the size of thickness of the slab. Here we are increasing the size of the column, but only this portion we are extending, not the complete column. And architect is okay with that because anyhow, after some time you may do a false ceiling and all that it will go inside. It will not look okay. Fine. Even if you don't do false in filling also, it's okay, but it will look good. Next one, what we have is both we are going to give. What is that? We are going to give the column head also, and also the drop panel is also given. So basically these are the four types of flat slab what we try to use. Okay, one is flat slab with drop panel, flat slab with column head, and flat slab with drop panel and the column head. Got it? That's it. Now, fine. Whatever I explained you, the same thing is explained here. Okay, fine. We'll try to understand it. First is increase the slab thickness by providing a drop panel. We already seen that. This is a drop panel what I've done. Second is increase the column size, that is give a drop head or a capital. So this is called as a, so this kind of structure, this kind of system usually in the airports and all you might have seen. They might have given a column something like this. So this is again, we know column drop, we can call it as a drop head or a column capital. Okay, fine. Next one is third option. This option here, what you do, increase the slab drop panel also, and also you give this column head also. Fine. Now, one thing you have to understand, this flat slab will help in the control of the deflection also. Why? Because usually what happens, see, usually this drop panel what you are giving, no, flat slab with a drop. This will help you in controlling the deflection, because when I give a drop here, this will increase the stiffness. Since it's going to increase the stiffness of this area, again the deflection also will not happen usually. So that is why generally what we do, we go with the drop panel only. This will, the advantage of giving a drop panel is it will increase the stiffness in this area. Since it's increasing the stiffness in this area, the deflection and all will be controlled. Got it? Yeah. Now, one more thing is this, what is that? Flat slab system, the failure is a punching shear. This punching shear failure, what is happening? It's a brittle in nature. So that failure is a sudden, it is sudden failure. It will not give you any warning and all. Suddenly the failure is going to happen. So it's written here, shear failure is brittle in nature and it happens suddenly, which leads to the global failure, catastrophic, and it's not possible to predict the shear or the brittle failure. So that is why carefully we have to design our flat slabs and all. And also when you do the de-shuttering and all, right? When you, because initially we'll give a props like this for the support and all, but usually what happens when we do the de-shuttering and all, we'll allow this particular props to remain there for at least, let's say, 25 to 28 days, and after that we'll do, because since this much area is very critical element for us, no. So that is the reason here we try to give lot of props and all. Okay, yeah. So this was all about the flat slab system. You got an idea like what is drop panel, what is this column head, what is flat plate system, and what is column head along with a drop panel. And also always remember, by giving a drop panel in a flat slab system, we can control even the deflection part also, because here more stiffness will be given. Got it? Yeah. Now in the next lecture we'll see about the load mechanism, like how the load transfer will happen in the flat slab, and I will try to understand that in the next lecture. So I'll see you back in the next lecture. Thank you.